This series of slides involves polar molecules, molecules in which the electric charge is not distributed evenly over the surface of the molecule. Let's find the pH of a 0.050 molar solution of benzoic acid, a naturally occurring acid. The first question to ask is whether or not benzoic acid is a strong acid or a weak acid. It's clearly going to be a weak acid because you remember that the common strong acids are only 4 or 5 in number. Now that we know that benzoic acid is a weak acid, let's write its equation for its ionization. Here, benzoic acid interacts with water to give the benzoate anion and the hydronium ion. Next, we'll write the equilibrium constant expression for benzoic acid ionization. The benzoate ion and the hydronium ion, their concentrations appear on the top of the equation, and the benzoic acid concentration appears on the bottom. Finally, we'll look up the equilibrium constant value for benzoic acid, 6.3 times 10 to the minus 5. When solving problems involving weak acids and bases, it's best to organize the information in an ICE table, where ICE stands for the initial, change, and equilibrium values of concentrations of substances in the reaction. In the first line of our table, we've listed the acid concentration, 0.050 molar, and indicate that before ionization occurs, the concentration of the benzoate ion and of the hydronium ion are both 0. Now the acid ionizes to some extent, and we'll call this amount X. This is the concentration of acid lost in the ionization, and so we put a minus X in the table for the change in acid concentration. This is also the concentration of hydronium ion and benzoate ion formed in the ionization, and so we put a plus X for the change in the concentration of each of those ions in the table. Finally, we need to know the concentrations of each species in solution at equilibrium. The acid concentration at equilibrium is the original concentration, 0.050, minus what has disappeared, X. The concentrations of hydronium ion and benzoate ion are both X moles per liter. Now that the equilibrium concentrations are known, we can substitute them into the ionization constant expression. Here, the concentrations at equilibrium of the benzoate ion and hydronium ion are both X. The concentration of the acid, benzoic acid, is 0.050 molar minus X. Okay, now let's solve this for X. To make this mathematically somewhat easier, notice that the value of K is quite small. The acid is relatively weak. This means that very little of the acid will be lost on ionization, and the little hydronium ion or benzoate ion will be formed. Mathematically, the important point is that the value of X, in particular relative to 0.050, is expected to be quite small. So if you were to subtract X from 0.050, the result, to two significant figures, would be just 0.050. Little error is introduced if we simplify the expression by dropping the X in the denominator, 0.050 minus X, and making it just equal to 0.050. We've just made our life much simpler. The approximate expression is much easier to solve. Solving the approximate equilibrium constant expression, we now know the concentrations of the species in solution at equilibrium. The hydronium ion and benzoate ions are both 0.0018 moles per liter. If we subtract the value of X from 0.050 molar, the original concentration of the acid, we find that the acid concentration has declined slightly to 0.048 molar. Our approximation was valid. Now that we know that the hydronium ion concentration in solution is 0.0018 moles per liter, we can find the pH of the solution. Recall that the pH is the negative of the base 10 logarithm of the hydronium ion concentration. Here we find that the solution has a pH of 2.74. It is indeed a weakly acidic solution.